Hi, everyone. In today's lesson, we're going to talk about a concept of increase and decrease. So let's just talk with an example. Given the graph of f of x, what can we say about the slopes of the function? What conclusions can you make? Well, when I say slopes, I really mean the slopes of the tangent line. So if I were to draw a bunch of tangent lines to this curve, right, they would all look in this way, right? So in this section, all the slopes would be positive, right? And then in this section, all the slopes would be negative, then they'd go back to positive, and then they'd go back to negative. So you can tell when f of x, when the original function is increasing, the slope of the tangent line is positive. When f of x is decreasing, the slope of the tangent lines are negative. And same thing here, when f of x is increasing, the slope of the tangent lines are positive. And when this f of x is decreasing, the slopes of the tangent line are negative. So those are the conclusions that I want us to make. So we can say when f of x is increasing, and we're not going to say slope of the tangent line, we're just going to say f prime of x, because that's what that means. So f prime of x will be positive. Right? So a positive slope of a tangent line being positive means f prime will just be a positive value. So the other conclusion that we can make is that when f of x, the original function, is decreasing, f prime of x, or the slope of those tangent lines, will be a negative value. Okay? So we're going to use this concept throughout the entire day today. We're going to say that, f of x is increasing. That means f prime has to be positive. When f of x is decreasing, f prime has to be negative. So if you can tell, f prime tells us something about the original function f of x. So we could write it in another way if we wanted, right? We could say if f prime, so we could say if f prime of x is positive, then f of x is increasing. And then again, if f prime of x is negative, then f of x is positive, or is decreasing, excuse me. So it could go both ways. One way, f of x tells us something about f prime, but f prime could tell us something about f of x. So that brings me to my next graph. My next graph is f prime. So given the graph of f prime, determine where the intervals where f of x is increasing or decreasing. So we just kind of wrote it. So I'm going to have it up here. If f of prime of x is positive, so then f of x must be increasing. I wrote it here. F of x is increasing when f prime is greater than 0. Greater than 0 means positive. So that's exactly what I just wrote down, but how does it look in a graph? Since f of x or f prime of x are y values, we're looking for the y's to be greater than 0. And what that means in a graph is that it's entirely above the x-axis. So where is my graph above the x-axis? Here and here. So because this is the graph of f prime, we can tell information about f of x. So f of x is increasing when f prime of x is completely above the x-axis. So let's write down those intervals. It's above the x-axis from x equals negative infinity to negative 3, and union from 1 to 3. And now again, f of x is decreasing when f prime of x is completely below the x-axis. And you can see here that it's below the x-axis from here to here and from here on. So we can go ahead and write that. So from negative 3 to 1, I'm completely below. And then from 3 on, so now I know it looks like I'm going down, but it's really 3 to the right. So it's 3 to positive infinity. And those would be our values when my function is increasing and decreasing. Okay, let's do some examples algebraically. So example 1 says, find the intervals on which f of x is increasing or decreasing. So remember, in order to figure out where f of x is increasing or decreasing, we have to look at the signs of the first derivative. So we need to look at the signs of f prime. So f prime of x tells us about the function being increasing or decreasing. So we must take our f prime of x first. So we're going to take the derivative using a power rule. So 3 times 1/3 is x. Decrease the power by 1 minus 2x. Bring this in front. Derivative of negative 15 is x is just negative 15. Derivative of your constant goes away. So we're going to do this exactly the same way that we did our standard position and our velocity. We're going to set our f prime of x equal to 0, and we're going to factor. So I could factor this by negative 5 and positive 3. And that gives me results of 5 and negative 3. And just like we did before, we're going to make a nice number line. This time we'll label it with f prime. We'll put down our negative 3 and our 5. And just know, because we're not talking about time, our graph can be negative or positive. So these will go to infinity or negative infinity. So what are we doing? We're plugging into our f prime of x function. So we're going to go into f prime of x. I'm going to do this by hand, but you absolutely could use the calculator if it's a calculator active question. So we're going to plug in some values. I'm always going to test 0 first because it's right in the middle, nice and easy. So if I were to test 0, it would be 0 squared, 2 times 0, and then minus 15. So this value in here would be negative. And then we could test a value out here, so maybe negative 4. So that I'll just do by hand. So negative 4 squared, 2 times negative 4. Minus 15, so 16 plus 8, and then minus 15, that's going to be bigger. 16 plus 8 is 24, and then minus 15 is positive. That works for me. And let's just test a value over here, bigger than 5, so say 6. So 6 squared minus 2 times 6, minus 15. So 36 minus 12, and then minus 15. So that's 24. Minus 15 will also be positive, so life is good there. So this f prime of x tells us information about f of x. So we can know that the graph of f of x, so f of x is increasing from negative infinity to 3, that's where it's positive, and then from 5 to infinity. So the graph is increasing from negative infinity to negative 3, union 5 to infinity. Now, f of x is decreasing from negative 3 to 5. And that's our answer. Now, please, please, please be careful. This is the f prime number line, and it's telling us information about f of x. So this is not, these values are not where f of x is increasing or decreasing. This is where f prime of x is above the x-axis or below the x-axis, or where the derivative, the slope of the tangent line is positive, or the slope of the tangent line is negative. So it's really important that you understand the notation and what you're being asked to solve for. Okay, so let's look at one more example together. So example number 2 is asking the same thing. Where is the function f of x increasing or decreasing? So I'm just going to put some steps down. Step 1, find f prime of x and set it equal to 0 and solve. Once you solve, you need to make an f prime of x number line. And step 3, if f prime of x is positive or greater than 0, that means f of x is increasing. And if f prime of x is less than 0 or negative, that means f of x is decreasing. So those are the rules and the steps that we need. So step 1, take the derivative, f prime of x. What you should notice here is that we have a product rule. We have x squared times e to the x. So I'm going to make this one my first and this one my second. So f prime of x is first times the derivative of the second. The derivative of e to the x is just e to the x, plus second, e to the x, times the derivative of the first, x squared. The derivative of x squared is 2x. We're going to set this equal to 0. So now what makes this really tricky is that it's not normal solving, not normal algebra. But what you should notice is that there is an e in the x in this term and an e to the x in this term. The parentheses might confuse people, so I'm just going to rewrite this as x squared e to the x, and I'm going to rewrite this as 2x e to the x. I just like the 2. Anytime there's a constant, I like to put it in front. If you would have wrote it e to the x, 2x, that's fine, but the constant I always like to throw in front. So the way that we're going to get around traditional factoring is actually by taking out GCFs. You should see that there's an e to the x here and an e to the x here. And we can also take out one of these x's with one of these x's. So let's do that. We have e to the x as a GCF times x. And when we divide that, these e to the x's will cancel. There'll be 1 left over x here, and then our plus 2. So we need to make a t-chart. But before we do the t-chart, we have to understand that everything here is attached by multiplication. So when it's attached by multiplication, that's where you separate your t-chart. So some people might need to rewrite it as e to the x times x plus 2, all in parentheses, so they can clearly see where my t-chart is going. So we're going to set each of these 3 pieces equal to 0. E to the x equals 0, x equals 0, and x plus 2 equals 0. So you'll see that this we can quickly solve and get negative 2. Negative 2. So we have one answer here, one answer here. Now there's something that we need to know here. There is nothing that I can raise e to get 0. So this is not possible. Now, just for purposes of time in this video, I'm not going to explain why, and I will go over that tomorrow in class as why this is not possible. And I'm going to ask that you finish this number line here for homework. So I want you to make me an f prime of x number line. I want you to put negative 2 and 0, give me some test values, and answer the question. And then also, please try example number 3, and we will start there tomorrow in class. Okay, have a good night.